Hello everyone. So in the last video I made for this series, we made a little delay and I show you the code in here. You can see it again really quickly. We have a feed forward delay and the feedback delay that inherits from it and makes some changes, and the rate handler for the different stuff that we need for tempo syncing the delay to the host project, and of course the main method that deals with the parameters and stuff. And if you want to hear how it sounds, then go back to my last video about making the delay. There are a lot of examples how it was made and how it sounds. In this video we will try to recreate this project in JUCE, and I will share this video with the people from the JUCE Discord and with the people from my PNS group on Facebook, and also on my YouTube channel in general, so everyone who follows me there can see the different benefits from each framework. And my goal is to not start a war which framework is the best, because there are enough people doing that. My goal is a rather noble one, which is showing that both frameworks have their use case and can be used and have their advantages and disadvantages and stuff, and we'll go over that very soon. And first of all, let's just try to recreate what we see here in the plugin script in JUCE. First of all, we need to open the producer, a program that was made by the JUCE developers to make it easier to handle projects. And there we just make a delay, I don't know, tutorial, whatever. Create the project with our default settings in our project folder. And now this is the files that are automatically created for us, and we just make our own file for our custom stuff, a little header file. And we already see one difference between AngelScript and C++. In AngelScript we only have the CXX and HXX files, but here we actually have a difference between header files and CPP files. But you don't necessarily have to know what that means in the beginning, because it's a rather intuitive concept, and it's really not that annoying. But you will very soon see some other things that are really terrible. But still, if you are on the PNS side and ask yourself, isn't C++ very like scary, then I hope that I will be able to show you that it's actually okay. And even though it does have some scary things in it, you will see that very soon, it also has a lot of things that will make your life easier. So now the first thing that we do here is we compile the project. Oh yeah, and first of all, sorry if this video is going to be long, because we actually have quite a bit of stuff before us. So now we just let it run, and while it does so, we just check the standalone, the shared code thing, and we see that it contains all our files very soon. Come on. Now here, the files. And now our compiled plugin should open, but not in Cubase or whatever door, but just in Visual Studio, and it opens fine. Now if we want to, if we wanted to open actually in our door, then we go to the VST3 builds thing and go to properties, and then we have to set our door as our door's path as debugging path thingy. Yeah, I love it. I love that you don't really have to know what you're doing, but you kind of get the idea. Okay, so now that we set that up, we can just, at the moment the standalone plugin is selected, then now we can select the VST3 one, and if we hit compile, it should give me a message that we have to restart Visual Studio as an administrator. And once we have done that, then it will be able to start our plugin in Cubase. Oh, but not yet. We have to change one setting in the producer. These are just the little things that you have to get to know, because it's actually not the default behavior to copy the plugin into our VST3 folder. We have to actively enable that for some reason that I don't understand, by the way. So if you are a JUCE developer listening to this little podcast or tutorial thingy, then please write into the comments why we have to enable that manually every time, because I don't think anyone ever would let it stay disabled. But really feel free to tell me in which case you would actually let it be disabled, or why you think that it's disabled in more than 50% of all times. Yeah. So now the door opens and we can see it doing its thing here. And now we can just make a fresh project and see if our plugin shows up. Delay. And we see it does show up. Yes, it works. And now we can, if we minimize our door a bit, we can test how the performance of the plugin actually is. But you can only take this with a grain of salt, because obviously in debug mode it performs worse than later in release mode. But you can already see how much RAM it takes and how much CPU it takes in debug, and when it takes only a few CPU in debug, then it will only be better in release. In most cases, actually I don't know if there is any other case. Now if we close the door at this point, let's just save that. Then the debug will stop automatically accordingly. Cool, that works fine. So now that works fine, let's just set the standalone one as the default one, again because it compiles faster. And let's start to make some parameters. Now this is our plugin editor. It includes everything from JUCE and the plugin processor. Don't mind this. This is just Visual Studio being weird sometimes. So now what does this mean? This means we have a class delay tutorial audio processor editor inheriting from JUCE audio processor editor, and everything that has editor or component in its name is something graphical in JUCE. Just have to learn the names of everything in the framework so you can work with it. So now what does this have? It has the audio processor as a reference. If you're coming from AngelScript, you don't know yet what a reference really is, probably because the way references are used in AngelScript is a little bit more limited than in C++. But actually this just means that this points sorter to the processor, and the processor is where the audio stuff happens, and this is where the graphical stuff happens. So the first thing I will do here is I will include our HDL thing, and I will also include it in the processor. And I think I will only include it in the processor, because when it's included in the processor, then it's automatically also included in the editor, because the editor has the processor included. So now we can just start writing stuff in our HDL file. For example, we can make a slider class inheriting from JUCE slider class. Now you already see one difference between AngelScript and C++, because in AngelScript you don't have to explicitly say public, only private things have to be explicit. But you would say something like this, do thing this is what it would look like in AngelScript, and in C++ it would look like this. And this has the advantage that you can just make multiple methods and they will all appear private, but you'd only have to say it once, so that's cool. And of course, protected exists too. So why am I doing this? Because I don't like the default behavior of the JUCE slider and I want to change it so that I don't have to change it manually for every slider. Set slider style. Now we have to call the slider functions and the slider style functions, and there we can define how our slider should look like. And this is going to be our parameter, and we want a rotary parameter, which means a knob, and it should drag on vertical movements, and that's how we do that. And if this seems very specific to you, then yes, it is. This is very specific to this framework, and you can also make your custom parameters in this framework, and it will work with the other features of the framework together, and that's pretty cool. And then you can just define it even better. Is read-only. Our text box is totally read-only, and it has no width and height because we don't want a text box. Just for simplicity reasons, this is my default slider setup. So now we can make some of these sliders. If we didn't have made our own slider class, then we would just do this now. And we will have a rate X, a rate Y, a feedback parameter, and also a retune speed. Actually, let's leave away the retune speed because I didn't like that in my last implementation a lot. It was just for experimentation reasons. So now, since we have made our own slider class and not just the JUCE slider class, we can use that instead. And it would look like this. Now we have the slider very nice laid out in here. And we can go into the CPP of the plugin editor where we define what should be happening to the visual objects of our plugin. And there we can just, first of all, activate all the things. Now this doesn't mean a lot yet, it just means that they are there and that we can use them, but it doesn't mean yet that they are shown on the screen. How do we do that? First of all, we go here. This is the paint function where we can paint literally anything, and we get rid of everything that we already saw. We saw the hello world message on some font and some color, blah blah blah, and we just replace that with one color that fills everything. Something dark, like dark cyan or so. No, that's just one color and nothing else, no text, no nothing. And in the resized method, we can define the size of things. We could do that in Paint too, but it makes more sense to have that in resized. So resize is called whenever set size is being called here. By the way, we can just say set resizable true, and then we can resize everything. And every time we resize the window, the resized method is being called. Oops. So that works. It creates some kind of glitch here, but I mean, at least it works, I guess. Param count is 3. We have 3 params, and by putting a point in here, we say that it's a double. We could also just say double in here, but in C++ actually we can just say auto on every type, so it's a little less typish. I don't know. Okay, so let's just make an X value. We initialize it with 0, same for the y value, and we make a width, which is get width divided by param count. We'll make a height, which is double of get height. And I made a little typo here. But the cool thing about this compared to Notepad++ is that it immediately shows me my typos. So I don't have to compile things to see that I made a mistake, which also speeds up the workflow a lot. So now in order to set the bounds of the sliders, I just have to say set bounds. And then I have to make a rectangle object, because this expects a rectangle object as an argument. And there I just give it the thing. And this doesn't work yet because it needs a rectangle of type int. So I cast it to the nearest integer. Now it works, and I can go on with the x value. Now I do that 2 times, and then I already have my nicely spaced parameters. That's what I always do when I make default plugins. Now you already have some kind of behavior that is very similar to the one in plugin script, where the parameters are just nicely spaced to each other and do their thing, I guess. And this is the default look and feel of the JUCE rotary sliders with vertical drag. As you can see, horizontally dragging them doesn't make anything now, and vertically dragging has the power, just like in most plugins. So that's cool. Yeah, cool. Now that we have that going, we have to think to ourselves how to get that over to the processor side, because just because we made some visual sliders doesn't mean that we can just use them. This is different than an AngelScript. In AngelScript, whenever you set your parameters in these arrays, especially in the first one, then from that moment on they exist. So you can just access them by saying input parameters of whatever value, and then that's where your parameter lives. And yeah, that's really easy. That's extremely easy compared to JUCE in C++, and you will see how terrible it is in JUCE. But I still would like to emphasize that the way that it's handled in JUCE is much more powerful, because it gives you a lot more options. It's just for testing purposes, this is just terrible. And yeah, let's just get started now. So we are in the processor, and we want to have an object called the audio processor value tree state. And already gives me the right object as a suggestion, and now I made this. What is this? This is an object provided by the JUCE framework that handles all the important stuff of our parameters, which includes like the synchronization aspects, like what if a parameter is being modulated by an automation, but also by a MIDI controller, and at the same time on the screen by the mouse that touches the parameter. Then a lot of different inputs come together. What should happen then? The audio processor value tree state handles all that, which is really cool. And it also handles undo management and preset management, and saves the state when the GUI is closed. That's all stuff that's being handled automatically in AngelScript, but this is how JUCE does it, which is pretty cool in my opinion. Now, in order to give this the information about the parameters, we have to construct it later. And in this constructor, we will need a method that gives it the parameters. So it needs a parameter layout, a so-called parameter layout, and we will return this parameter value layout to the audio processor value tree state very soon. So now, how is it implemented? Now this is the initializer list of our constructor of the delay tutorial audio processor. You don't know yet what an initializer list is. If you come from AngelScript, that's basically a list where we initialize all the values. And I'm really sorry that the first initializer list that you ever saw in your life is this monstrous thing, because actually initializer lists aren't even that complicated, but JUCE makes it look terrible. But we just have to add our thing here, and now we give it the information. First of all, this, so it knows about the processor. Then null pointer, because this is where the undo manager lives, as you can see. But we don't want to undo anything. We don't need an undo manager now. So we can just say null pointer. Then we have give it an ID, because we can have multiple audio processor value tree states, so they all have to have their own IDs. And now we give it create parameters, which will return our parameters in here. Now we still have to implement the create parameters method, so we go down and just do that. How do we do that here? Well, first of all, we have to write that again. Parameter layout. So it will return a parameter layout, and it's part of this class, and it's called create parameters. Thanks for the suggestion. So now we have this method, and I already have a nice plan what is going to happen here. We will make a vector of unique pointers, and the cool thing is you don't have to know what that means yet. It is just a thing that is neat here. And when I started with C++, I was a bit confused about that, but the cool thing is you just have to use it. You don't have to know what it means, and at some point you will be interested what it means anyway. What's much more important here is what's in ranged audio parameter. This is the thing that holds the information of, let's just use an int one. Oh no, that's wrong. Oh yeah, this is just a general ranged audio parameter. Parameters. This holds the information about the range and the interval of your parameters. So this is basically what this is for in AngelScript. Right? Okay, cool. Let's go back. Now in the end we have to return that. But we don't just return the parameters. We rather return kind of, what was the name for that? I forgot what it's called, but it's kind of, it kind of points to it, but it's an iterator. Yeah, that's it. That's how we return an iterator that has this range from begin to end of the parameters vector. Yes. Okay. Now we have to push back our parameters. Pushback is a method from vector, and vector is just the same as the array in AngelScript. But you already see that it's really cool that you can just put custom objects into this vector, while in AngelScript you can only use primitive types for that, which is really annoying. Even as a beginner, that's really annoying. And that's why I even encourage beginners to learn C++, because C++ does make things easier sometimes. It's not always terrible. Okay, audio parameter. You see we have some different kinds of parameters here, and obviously we want to use the integer parameter because we will make a range parameter. And we have to give it an ID, ratex, for example. Now the next argument is the name. This is going to be shown on the screen. I mean in your DAW, how it's called in the DAW is defined here, and then we have to set range, like from 1 to 64, yes. And then our default value is maybe 3, because I want to make a 3/16 rhythm as a default value. Now we just repeat that 2 times for both of the other parameters, and just tweak this a little bit. And of course the last one, feedback, is a float. I wonder why they didn't add a double audio parameter, or did they? No, they didn't. Okay, there's only float, but I guess it's good enough. Okay, now in this case you can't just go on like this with the arguments, because we have a floating point audio parameter. So what you need is a normalizable range object of type float, and it has the arguments start value, end value, and the interval of each thing, and then the next argument is the starting point. Let's set it to 0.6 because this is usually very conservative, but still pretty strong for a delay. Now that we set up these parameters and also returned them to our APVTS object, we can be sure that our APVTS object expects these parameters. So now how do we give the parameters to the APVTS from the plugin processor? That's the question, right? So we can just make a type def in here. And I will say very soon what that means. This whole line basically just says, yo dude, this is much too long. In the future I will just have to say this to say this. Okay, and that's what it means. It's just redefining stuff, so I don't have to write such a long statement here. And now we can make so-called slider attachments. So now we added 3 attachments. Actually, they have to be unique. Oops. I don't know yet why these have to be unique pointers. Maybe there's another way, but there are a lot of different ways how to structure your code in C++. And this is just the way that I found works for me. And sometimes you don't have to really know why it works, but you will find out at some other time when you get experimental anyway. I had that so often yet. So now in between of the stuff that says something general and the stuff that adds our parameters, we add the combination between the visual aspect of the parameters with the auditory one. And that's by saying ratex attach is, and now we define what it does. Make unique as attach audio processor APVTS Now we have to say the ID at that point, and of course we also have to say which slider we mean. We mean the rate X slider. I say of course, but actually I'm pretty sure that you don't find that very obvious if you don't come from C++. But yeah, that really seems scary first, I guess. Now we just do that for all the other parameters and stuff. Have to be really careful here. Many people would advise you to save these values in some global kind of thing, but let's just do that manually now, so you can directly see what's in here. Now we made the attachments, and that should work because we have the audio processor value tree state as an argument here. So this basically combines them together, and now it should work. Let's just test it for now. And we see that it works. Now let's change something. And it changed itself back. Why did it do that? Because we didn't implement the stuff that makes the presets work yet. And yeah, there's a tutorial on that on the JUCE website itself, so I shouldn't do that too much in this video, but I want to do that because later when we'll make the delay, I don't want it to jump back all the time. But I will just go very quickly over it and just copy stuff from another project, so you can like inspect that yourself if you want to. And it's always the same in every project, so you really don't have to be understanding this too much. It's basically just saving the current state in an XML file and then loading the state from the XML file whenever the editor is created again, because the plugin editor is always constructed and deconstructed whenever you open or close the GUI. So all these connections have to be made again then. I guess that's the reason why there's a unique pointer here. I don't know. Okay, now our presets should work. Yes, it works. Nice. Okay, cool. Now that this works, we can actually start working on our nice delay implementation. So we make a namespace with our nice company name or whatever, which is in my case HDL Audio. And now we make our delay class. Class feedforward delay. Now we have some public stuff and some private stuff. What do we need in the private stuff? First of all, we need a vector of doubles, because let's just define everything as double, so we have better processing and stuff. And this is only going to matter if we use interpolation anyway, but whatever, let's not be cheap here. And this is our data. And then we will have a write index, and we will have a, yeah, let's just go on for now. So first of all, yeah, the first thing that we want to do here is set the sample rate. Yes. The reason why we have to do that is, if you come from AngelScript, you might ask yourself, what's this? This is setting the sample rate. Let's see. It was solved in my other video by just in the constructor saying the size of the array should be sample rate times 5 for 5 seconds. But we can't do that in C++ because the sample rate is not known at time of construction. So we have to give it later to the object. And now that we have created the sample rate here, we can just say data resize to fs times 5. Actually, this doesn't give us an error, but it's a little bit unclean because, as everyone knows, this is a double value and we need to cast it to int so that it can actually resize an array or a vector in a way that makes sense. Everything else is just silly. Cool. Now, how do we give it the sample rate? In the plugin processor, there is a method called prepare to play, and this has the sample rate. So you just go here, and oh yeah, of course, you just have to create a delay object first. Now, the thing is, this would just mean that we have one delay, but we want to have 2 delays for each, one for each channel, of course. So we include array. And yes, I had this discussion lately with the other people from the Discord saying that I could use vector instead, but I totally know that I won't go over 2 here. So let's just use it an array. And now we have 2 delays, 2 feed forward delays, and we will change this to feedback later, of course. Now that the delays exist, we can loop through them. Now the method prepare to play is being called whenever the sample rate changes, which is pretty rarely. If you're a producer, you know that it's pretty rare. So it doesn't really matter if there is anything not very performant in here. Just saying. Cool. Now, because I'm saying that because resizing the array is not very performant. I mean resizing the vector. If you want to know more about that, then check out the new video from the Cherno. He recently uploaded a video about making your own data structures, and as an example, making your own vector class, which really was a really eye-opener about how incredible this object is. Okay, cool. Now let's write a processing class. And we will write it as a virtual function because we want to override it later. And it will return a double value, and it also has a double input. First of all, what does it do? It just puts the input into the vector at the current write index. Okay, this is basically it, but we also have to move the write index forward. I guess we can just take it simple here and just return the value here, because then we can say write index go on. Actually, let's make this a little bit simpler by implementing the size function in here. That's cool because we can just say size. The reason why this looks so weird is because we don't return the thing that we put into our array here, because we need to increment. But we could also just increment before, and only then. Hey, what's that? I must have changed something. What? Okay, what the fuck? What? I can't use CTRL anymore. I can't use any of the CTRLs anymore. Okay, what the fuck? What? Okay, I guess. Can I copy this? Yeah, it works again. I don't know what I did, but whatever. Now, we also need a read index, and the read index is going to be double, and and we need a delay value. Now let's pretend we already set a delay in samples. Now the read index must be, considering that the write index is always the present, the read index is in relation to that minus delay, and this of course can be below 0, and if that's the case, then read index is being put up back to the size again. And now what, because this doesn't look very nice, we will add a little increment function here and just put all that stuff in there. And now we return something, but we also have to write the return function. Yes. So now at this point we can just get sample, and that's it, I guess. Ah, wait, what am I doing? Oops. We return get sample, of course. So now this is our process function in C++, and we can make this virtual as well, because we can later exchange this with other interpolation types. But let's just put that in here, or at least in protected, so that when we inherit something that we actually see this function. Okay, now we of course we have to set the delay in some way, and we will set it in samples, and D stands for the amount of samples. Now let me quickly check how I did that in my other implementation. Delay is clamp of D. Okay, cool. Yeah, of course. Now let's make a little utility class, or we'll make it struct. Structs don't exist in AngelScript. Their purpose is just the same as a class, but the difference is that the default behavior is being public, so you don't have to be explicit about it. Now we'll make a static method that returns a double value, and we call it clamp, and it takes a double input D and a size, and we say if D is still smaller than the size, then return D, and else return size minus 1. Now this is our nice little clamp. We can just make use of that in here. Now we have a function for setting the delay in samples, and we can just use that very soon. Yeah, actually we could just test that already. I mean, when we can set the delay in samples, then we can process stuff, and we can set the size in here and everything. So let's go back to the processor and to the process block, and let's just delete everything in here except for the thing with the denormals. This thing handles that extremely low values won't make the CPU work too hard, which is very useful for a delay, especially for a feedback delay, because things are getting quieter and quieter, and then suddenly the CPU has huge spikes in AngelScript, which is not the case in JUCE. So as you can see, this is the process block method. It has two arguments, the audio buffer and the MIDI buffer. In plugin script, that's just the same object, but it's just one argument. Now we make a little for loop here. Auto as starts at 0, as is smaller than buffer, get num samples. This is our sample loop, obviously. And now our channel loop. And now one of the biggest differences is again the flexibility that we get for being able to make an array of our custom objects compared to what we had in AngelScript, where we had to make two objects instead. So the for loop looked a little bad. I have to let my cat inside really quickly.
Spaß. Miau. Kleines Kätzchen. Miau. 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 Miau, miau, miau. Miau, miau,
miau. Alright, I'm back, and you had some time looking at this main method, this process block, looking really bad because we go through the sample loop twice, and in the second loop we check if the audio outputs count is bigger than 1 or not 1, and this looks pretty stupid compared to what we will do now. We have our channel loop here, and we just say delay process. No, delay of current channel process. And what do we process? Yeah, well, we need an object that we can process. We need something like data samples. And what is that? That is auto sample is buffer get right pointer of channel and sample. Bam, that's it. That's our sample. Our sample is contained in this pointer, and in order to access this pointer we have to do this. And of course we know that our process also outputs a value, and we just add that to our sample. So we hear the dry signal and the wet signal. And now all we have to do is add a delay. And let's just say that this delay has the length of whatever. This would usually be 1 second. But if it's not exactly the sample rate that I'm on currently, then it will still make sense, kind of, just for testing purposes. And yeah, I think we could just try that now. Oh yeah, I have to open it as a plugin, obviously. But it's nice that it starts at all, I guess. Okay, now it would be cool if we had some audio in here. So we see that it works. It definitely is a delay. But in order to be able to have more different tests with it later, we will have to construct a little groove. Yeah, these are maybe not the best samples of all time. But I don't care, we just need a little beat. Okay, I mean that's good enough, I guess. My cat is demanding my attention. Okay, so now we have something to work with when we open the plugin the next time. So now that we know that it works, let us implement the feedback delay. Therefore, we just make a new class and let it inherit from our feedforward delay. Sounds like my cat wants to go outside again. Wait up.
Kleines Kätzchen. Lauf.
She's so lovely. Okay, let's go. So first of all, in order to make a feedback delay, we need a feedback method. And of course, for that we need a feedback variable. At this point, everyone would still say, yeah, totally. And I think the message should come across that even though the graphical stuff was much more easy in plugin script than in JUCE, that the DSP stuff actually feels a little bit safer in C++, at least to me. So let's just let me open the implementation that I had on another screen so I can compare that, because I don't want to think too much now. We have to make a process method and then we have to increment again. We have the increment function. Oh, this doesn't work because the other increment function was private and it should actually have been protected. Now it works? Yes. Okay, now data must be protected too so we can access this. Actually, I think we need all of that protected. Don't need private. Okay. Now the difference between a feed forward and the feedback delay is that we don't just put X in here, but we instantly put our Y sample in here as well, times feedback. And if we wanted to be really safe that this can't break out massively, then we would also wrap some kind of wave shaper around it. And I think we will just do that. You could use any wave shaper function here. Let me just quickly check what else is in the other method. I think that's it, yes. Yeah, of course we have to return something. And in this case we return actually we can just put it in here directly. As I just saw, we have to make a little step in between. Or do we really have to? I'm a little confused about my other implementation that I did last time, honestly. No, let's just let us just return it like that. I think that's sufficient. I hope so, at least. So now let's set a default value for the feedback. Or did I do that here? No. No, not really. We should set default values though. And for that we have the initializer list that I was talking about earlier, and as you see, actually this is just really easy. It's just a list of default values. This is what it essentially is, nothing too fancy. And the one in JUCE just looks fancy because it's very advanced. The problem is, even though this all of this worked, there is no a clear definition for these things having to start at 0. While in AngelScript their default value is always 0. In C++ this is undefined behavior, so you have to manually make sure that everything is 0. For example, in the in the resize method, I will make sure that whatever compiles this code will always have everything start at 0 and not clipping. Okay, now we have to make the same for the feedback delay. Now there's one thing that I would have to Google now, but I think I will not do that, because actually we have to call kind of the other constructor in here somehow, and I have one project where I did that, but I forgot how, so let us just pretend I did that here and call it a day. Yeah. So let us compare this with the other implementation. In AngelScript, for setting the inheritance, you don't say public, you just say the name of the class. Also, the class can be defined later than the class that inherits, which is not the case in C++. And also you can just override the function like this, while in C++ you have to be explicit about that by saying override. Now the compiler knows that this is going to override the old process function. Now we should be able to use this by just changing our delay to feedback delay. And now we set a feedback. Cool, that works. So yeah, our feedback implementation works very well. Now, the thing that you might ask yourself now is, how do we get the parameters to work with everything? And what I like to do is usually have my custom DSP handling class in here, but we'll make a very broken down version of that for this video, because it's far too complex to just write that on from scratch. We make an enum called param rate x, rate y, and feedback, because we know they come in this sequence. And now we can just go to the plugin processor and make a vector of atomics. Or can I make vector of atomic floats? I don't know. Let's see if that works. Parameters. I guess it works. Okay. Now in the constructor of our plugin processor, we can just say parameters pushback, and now apvts get raw parameter value from the parameter ID rate x. I think it doesn't like that. Yeah, the atomic float type is a very weird one. I think the atomic float only likes, oh wait, sure it does like that. I know that because I did that in my other implementation, but why does it not like this? I think, let me just look really quickly in my other project why that's the case. Yeah, that's one of the disadvantages of the complex way of making plugins, that you keep running into things where you forgot why things were the way they are. So you have to look how you solve that in another example. I think this is it, yes. Okay, let's see, we have the parameters and blah blah blah. Oh, okay, I gave it the same name as some other parameters, or no? No, this should be it. That's weird. What does this expect? I don't know why this doesn't work. It works in my other implementation as well. In my other implementation, I just have it here. And wow, this would work. Why? Okay, whatever. Let us just pretend that I understand why this works and the other thing didn't. Oh, I know why. Yes. It's the detail. Yeah. Sometimes it's details that make it work or not work. Okay, cool. So why is this an atomic float and not just a float? You might ask. It has something to do with the way it's accessed in deeper levels of the memory. I have no idea about that stuff, so let's just keep it like that. So now we pushed the parameter pointers into this vector, and in process block or wherever you want, at the start of the method I usually have to have a little function call, which is set parameters and a function. Or actually process. Process parameters is a better name for that. But then again, we also need a little something in here. A vector that is just for the parameter output, not just the atomics, because now we can just say params of HDL param rate x equals parameters at the same load. So why does this not work? Oh yeah, because this function doesn't know that it's part of the class yet. Therefore we have to define it earlier. We have to be process parameters. So now it knows that this is going to be implemented. Parameters. It doesn't like parameters. What? It knows parameters exists. Oh yeah, right. It's a pointer, so we need the arrow, of course. Now this is how we get our pointers into the actual vector of doubles, and of course then they are just there and we can use them. In the case of the feedback, we can just put them directly into our delay. And then the delay will manifest. We could test that now, because we haven't implemented the rate thing with the tempo sync stuff yet. So it would be better if we just tested it like this for now. So let's just bring back the implementation with the fixed delay really quickly. Let's just make it a shorter delay now. Yeah. Okay, now we should have a delay where we can change the feedback and nothing else. Cool, let's try that. Cool, I get an error. Why? Vector subscript out of range. So now you can see in action how the debugging works. Also a very important aspect. In line 142 there's something that doesn't work. Why? Because params has a size of 0. Yeah, of course. It makes sense. Because at the end of this, we have to make sure that it actually has the same size, obviously. Now, if you are familiar with AngelScript and know how debugging works there, then you probably have just seen that it looks a little bit different, but it's still kind of familiar. It shows you where the line is that has the error and what the error actually consists of and stuff. Gives you some details. Yeah, beautiful drum loop and a beautiful feedback functionality. Cool, now that we have the feedback, let's check out how we would make the rate handler. The thing is, this will look really different in C++. So let's just go ahead and copy this for now into our HDL on maybe before the delays. First of all, let's see what happens if we only copy that just like it is. It needs to know the sample rate, so obviously we have to give it the sample rate. Apparently, that's already it. This is all we need to get the correct tempo. What? Yes. Okay, so we needed to know the beats per minute and the rate X and Y, and that's already it. Yes. Okay. Yeah, looks cool. When does this give true? If everything is alright, then this gives true apparently. So now what we can do about this is actually find out how to send the data to about beats per minute to our process thing. First of all, let's make an object of this. Rate handler. And as we've seen, we have to give it the sample rate. Cool. Now that we have given it all the information it needs, it can work. And we can just go ahead and probably will need to implement something here, since this is the place where we set the rates. And but this is not the place where we have info about the audio buffer and the MIDI buffer. So maybe rather find a way to implement it here first, make it easier. Let's take this away again, we don't need it now. In order to do that, I will look into a different project that I have where I implemented tempo sync features as well, so I don't have to riddle about that now, because I don't want to waste your time. It is similar to the way it works in AngelScript, it just has different names and some special stuff. So let me just quickly check for it. Yeah, okay, cool. So the first thing we need an object called a JUCE audio playhead with the current position info. We just call it host info. By the way, if you are asking yourself about things in this framework and maybe you ask yourself how to come up with this stuff, there are different ways to do that. For example, you can just hold CTRL and click on something, and then you can read how the JUCE framework works, and sometimes there are nice notes that describe the thing. While in PNS you have to go into the manual to read about it, which is kind of annoying sometimes. Or we go into the other object. Where was that? Into this one. Now we have oh, that's the same file. Okay, cool. Another way to learn about the JUCE framework would be to say JUCE audio playhead, and then just go to the docs. Online it will also show the same information, but in a slightly different way, if this is more comfortable to you. And yes, this is just dark mode. So it actually looks like this, but it's bad. This looks 1,000 times better. Yeah. Okay. Okay, now in process block, we have to make sure that the host can actually that the host actually has a playhead. So we call get playhead, and if the host does not have a playhead, then this is going to be a null pointer. If playhead is not a null pointer. So if we have a playhead, then I think at this point we can already get information from it. initialize check, get current position. Oh, this is where we have to give it the current project position. And now the host info knows about the current position, I guess. Yes, now we have the ppm argument already laid out for us. Now all we need is I would like to have this whole thing in here instead, because then we can make a check if anything about this has changed, because else it will become very expensive. So now what we do now is this. And then this. And now we say if rate x is not this value and or rate y is not this value, then stuff should happen. Obviously the first stuff that happens is that we replace the value but first of all let's try to get the BPM stuff in here. Now, if we have no playhead, then this all is completely useless. So we can just put it in here. We have to store a little helper in here. Current BPM with the default value on -1, which makes no sense, of course, so that this is called at the first hit of this function. BPM is not oh, we have to call this before. Okay, BPM is not this. Then obviously it will be put to this. Now we have a code that only changes something when any of the important aspects have changed, and we can work with that now. Since we have this structure, we can just leave the if statements away now, because I don't think they really belong here. It was a mistake to even add that. Now this looks much more neat. Okay. I don't think we even need to save the BPM in here, because we don't use it later. Let's make it really as simple as possible. X rate, Y rate, bars per second, bar. Oh, this is all we need in the end. So we don't even need this. We just need the rate processing. Yeah, really not sure why I even made it so complicated first. However, now we have the process and the get rate function, and I forgot to end this class. Come on, yes, cool. Now I don't need this, I don't need this, and this. Nothing of that is needed anymore. So our rate handler now can handle things. Yeah. Now we can access the rate that we constructed. Actually, let's just return it here. We don't change anything about the internals. Can just get rid of this. Now we don't even need this. Just need this. So now we get our rate back. And that means that we need an actual rate value. And now that we have this, we can just update our parameter, our delay. I think that was it, but I also think something was missing. Is this really already how we get the rate to work correctly? Let's see. Rate handler. Where do we use the rate handler in our original implementation? Set delay in samples. Get rate. Yes. I think get rate really returns the value in samples. But the name is a little bit misleading because a rate is not an amount of samples. I guess it was a mistake to call it like that. But yeah, I guess that should be it now. So let's just test it. By the way, I'm not even sure if the audio worked from my audio workstation all the time. Okay, cool. It works. Now in my other implementation we had something that smooths out the delay when it goes from one way to another. In the case of this implementation, we just said that for each call of process, some delay index tries to move towards the destination, which was the R index or something like that. I decided that this is too complicated and I want to try a different approach. We already have this rate in here, which is like the rate that is just given by this function. We could call it rather call it delay destination. And then we also have the current delay. And then instead of just calling it here, we have to outsource this again and call it a little bit more often. Hello? Can you please get normal again? Oh, right. We already have a delay object. Delay current. Okay, whatever. Or let's call it R index, because it's the index that reads. Or is it? No, not really. Oh, I can't name things. Delay current. That's it. Cool. Now the delay destination will always go through the value that we want, and now we just have to make the delay current follow it for each sample. So for each sample, delay current plus the some very small value times delay dest minus delay current. Now that's how we make the delay current follow the delay destination, and then for each sample we say we go through the delays. Actually, we can use the channel loop in here for that. And now this is the value that would be equivalent to our retune speed. And now I guess this is a very low retune speed. Or let's just implement a retune speed really quickly. And we define it in our process, in our prepare to play as, let me just quickly see what our default value here was, 8 divided by sample rate. Okay, let's just take that. And then use this value here. Now this should work. Let's see. Okay, what? now, I guess we recreated the delay from our last implementation completely and even improved some of the aspects. So now it's time for a little resume about what is different between plugin script and JUCE. The main part of this video finally started. So first of all, we started with the implementation of the editor. We had to make a lot of slider stuff and a lot of attachment stuff, which is all stuff that you don't have to do in plugin script. Then we had to define how everything looks. We had to define where everything is, and we have to attach things to the processor, make them visible and all that stuff. You don't have to do that, but you see this is very powerful and also a lot of fun. You can set GUIs resizable extremely easily. You can paint things just in this method. You can set any behavior you want in the resized method for resizing things. And you, of course, we only have scratched the surface. You know that because there's only one line in our paint function, because this video is not used to show you what you can do with paint, but there is a lot that you can do. So if you want to get into graphical programming when it comes to VST plugins, then you should really start with JUCE and not hang on with plugin script. You should use plugin script if you just want to test things and are far too lazy to make all this parameter stuff every time you just have a little DSP idea, because that's just annoying. And even someone who works exclusively in C++ up until now should see that this really doesn't make sense if you can also just open a new script and make it so long. And that's it. Really 1,000 times easier. So this is a definite benefit for plugin script. And again, I'm not trying to start a war here, but I know that people are like always pretend like you have to be on one side or the other, and I rather like to focus on where the different advantages are and use both frameworks in conjunction with each other. Now we have the plugin processor, and we already had the huge advantage here that we could just put things into arrays and vectors, custom objects, and very special types of objects, of primitives types and pointers and everything. Pointers don't even exist in AngelScript, which is a blessing if you just start out, but after a short while you will want to use and work with pointers anyway, because they have a lot of advantages. You've already seen one of the advantages, like in the constructor, where we just said no, we don't want an undo manager now, we just set it to null pointer. That's something that you can do with pointers. You can just say, yeah, I know there's an argument that expects me to give it a pointer, but I just say there is no pointer, and then the argument will say, okay, whatever. And you can do that with normal values. Yeah. Now, another huge advantage of the JUCE framework compared to plugin script is that it has the prepare to play method, because in plugin script, if the sample rate was changed, then I don't know what would happen actually. I mean, we set the size of the array in the constructor of the delay and set sample rate times 5 for 5 seconds, but what if the sample rate changes? It will not just call the constructor again, or will it? I don't know, because if it won't, then this will totally not have the right size then, and I haven't tested that yet. But if it will, then okay, then this is really smart. But yeah, I mean, it's still a little bit weird from the way it is being called, and it's just much more. It makes much more sense in here, where you know that this really called whenever the sample rate changes. So you just put all your sample rate stuff in here and know that it will be fine. Yeah, but of course, if you just want to test something really quickly, it's nice that you can just set sample rate at any point. You don't have to pass it around from a given function. You can just make a new class and call sample rate at any point of it. So that's cool. That's really cool. Yes. I think you could even use the sample rate while creating the parameter ranges, which you couldn't do in JUCE. And yeah, process block. Yeah, process block is really nice. We have a separation between the audio buffer and the MIDI buffer, something that we didn't talk about in the video, but that's cool because it gives you really different functionality for both of these, and we can set the scope to denormals to no denormals, and yeah, I could show you how the plugin script plugin performs without the scopes no denormals. I mean, let's just do that really quickly. If they haven't fixed it yet, I should bring the point across. And I guess this video is far too long already anyway, so let's just make it even longer. Now let's add the script from last time. Oh yeah. Okay, this is the script from last time. Let's disable this one for now. And let's just play something back and look at the performance. And of course we don't have sound. Something is disturbing the functionality of everything. I think it has something to do with the audio driver. What? Why doesn't it like that now? Okay, then I guess I have to switch over to my other audio driver, and you can't hear the audio, but I guess you know how the delay sounds already anyway. We just have to look at the performance meter. Where's the performance meter gone? Okay, weird. It seems to work fine today. I think the last time I tried this, it actually started doing weird things, but maybe it was a user error from my side then. Cool, then I guess this point is saved. Then I guess plugin script also scopes the denormals. Fine. Cool. Then I'm positively surprised now. However, in JUCE you have to actively call scope denormals to scope denormals, then process parameters in plugin script. If you were to just say something like this inside of your process block or even inside of the sample loop, then it will call the parameters from that sample and not from the whole block. In JUCE, you always get the sample from the start of the block. But I think that's cool because in most cases you don't want it to be faster anyway, since processing power and everything. Now in JUCE you get the transport and BPM just like this, but there is no checking if this even works. So this could yield an error. While in C++ you check if the host even has a playhead, and only if it does, then it will do stuff. By the way, we don't need that here anymore, since we have it in our process parameters. Yeah, a lot of stuff looks a lot harder in C++, but actually makes sense, and it still says the same thing as it would in AngelScript. And it's also more beautiful because this IDE just looks so nice. And then we just get our delay destination from our rate handler that does its neat thing. And yeah, we could tidy up this a bit by making a class that handles all that as well. But I mean, for this video it was sufficient. The feedback didn't need such a complicated thing. And yeah, we made it work pretty easily. We also saw how inheritance works with virtual methods and override. It's actually very similar to the implementation in AngelScript. And if you've seen my other video, then you know that my processing looked a little bit more complex there, but that was just because I was a little bit weird at that day. And then I slept a little bit about it and thought of it and realized I can write it much easier. And I could have written it like this in AngelScript as well. So this is actually really similar. And if you come from the AngelScript side and ask yourself if C++ is cool for you, then just remember that it's actually very similar to AngelScript. AngelScript is based on C++. And if you can write in AngelScript, you can also more or less write in C++. And if you are a C++ person and ask yourself if it's really worth it to learn another language, especially if it's just a scripting language, then please consider that you don't really need to learn a language if it's about AngelScript. AngelScript's almost like C++, and there is nothing to learn about that. You will just jump right into it and write your code. Yeah. How many lines do we have here? 87 for everything in this header file, including the slider and the parameter stuff and utils. How many do we have here? 82. So actually it's pretty much the same. Of course we made some things a little bit easier in here, but yeah, it's still pretty much the same. And there isn't a lot of a difference between AngelScript and C++, especially except in performance, I mean, but you can use both frameworks and just enjoy yourself. And that should be the message of this video. And that I made a nice delay. Yeah. See you.